Hello, dear friends. Today we have here with us Kyla Morenz, who's an elementary trainer. She came to Bucharest for the second time this year. And today we are going to talk about learning. Welcome, Kyla.
Thank you.
Learning is a huge topic for teachers, parents, whoever is around children. What are the conditions for a child to learn? The children don't just learn. They need some conditions.
Absolutely. Learning is something that we all think about when we get older, but it's not something that we consciously think about when we're young and doing so much learning. If you think about, the child just after birth in those first 3 years, they're not able to hold their head. They're not able to feed themselves. They can't really move about their environment on their own, but they learn to do it. We don't teach them in the same way we teach children who are older and who are in school, but they learn anyway. So what is it about those conditions of their environment that allow them to do that learning? And it's really about them being active, being able to try things, to make mistakes, to interact with the people in their environment. So mom and dad at home, aunts and uncles, extended family, they observe their environment. They look at things, they reach out, they touch them, they hold on to things because that's how they can learn about their environment. They pick things up once they're able to grasp. And what do they do with it? Often put it in their mouth because their mouth is very sensitive. We learn a lot through taste, through just how things feel, soft and hard, prickly. So it's through that interaction with the environment that the children are able to learn. They listen to the adults talking languages around them, and that's how they learn a language. There isn't anyone, sitting there saying, okay, now say ah, we don't teach them the alphabet before they can talk, but they still learn a language anyway. And they just seem to pick it up kind of miraculously. And I have to say, as an adult, I'm a little jealous of how easily they learn languages at that age. I'd love to be able to still do that. So there's something in the environment that engages the child, attracts their attention, and they focus on it. And through their senses, their brain is able to rearrange itself, make new connections with neurons, and they learn.
Before the age of 6, especially before the age of 6, without senses, the children cannot learn anything. Is it the same after the age of 6?
Well, something different happens. And neuroscience is really, because of the new tools and technology, is really able to look at what's going on inside our brains. And it's fascinating. And so, that young child, those neurons are just multiplying in huge numbers until somewhere around the age of 3. And then they start to reduce a little bit. But at age 6, something happens in the brain that changes. And even before neuroscience, even before school, as a formal institution was created by humans, there's this recognition that somewhere around the age of 6, we can actually start to train children where they just start to be interested in what the adults are doing around them, how they're using tools. How do you use a fishing rod to go fishing? How are you carving that piece of wood to make a sculpture?
How do you drive a car?
How do you drive
a car? How does it work?
Yes. How does it work? What is it? What's inside the computer? How does the computer work? What's it? I remember as a child wanting to know about the typewriter. That, the mechanical typewriter, the one that you really had to push the buttons hard on. And I remember wanting to get it down, and it was big and it was heavy. I almost dropped it. Fortunately, not on my toes. And I was trying to lift it up and look inside. My mother came and stopped me because I wasn't taking it apart properly. And she used that typewriter for work, so I couldn't take it apart. But
I remember I wanted to dismantle the clock to see what's inside.
It's fascinating to see all those gears and what is it needed for. And that's really, that's where the child's mind goes. What purpose does each piece have? Why is it there? Will the clock still function if it doesn't have this cog or this wheel? What happens if, we change the conditions a little bit? Do things happen the same way?
Mm-hmm.
So their mind goes to this very scientific approach, actually, to thinking about their world. What if we did it this way? And that's sometimes what children say to their parents who are just thinking, we just want to get the dishes cleaned up after dinner. They're like, but what if we didn't clean up dishes? What would happen? It's a thought experiment for the children, because they know that, well, we've always cleaned up dishes after dinner. But what if we didn't this one time? What's going to happen then?
So they learn questioning. And because they learn questioning, maybe the adult needs to have a certain attitude towards this kind of learning, which is different than the child who's just taking in everything the adult does, the way the adult does before 6.
Yes. Before 6, you ask the children to do something and they're like, okay, happily. But then they turn 6 and they go, well, why? Why do I have to do it? Why can't you do it? What if I don't want to do it? Or not even asking that question, just saying, I don't want to. And it is a little different, because what is behind those questions or those statements of, I don't want to do it, it's not fair, how come I have to do it, is that I want to understand why this needs to be done, when you want me to do it, the way you want me to do it. What purpose does it have? What happens if it doesn't happen now or happen at all?
Mm-hmm.
What's the result? What is the consequence of doing this thing or not doing this thing? And that's, these children, because of that, are really interested in thinking about the universe and thinking about how everything is connected. And we know, as human beings living on this earth, we know how important the earth is to us. And we have a lot of concerns now about things like climate and endangered species. These children are curious about the world, and so we can talk to them about all of these things. But the question, I guess, when it comes to learning is, how do we talk to these children about topics like this?
Are we willing to make them reason instead of giving them the answer?
Yes. Yeah. Are we going to feed into their curiosity and help them ask questions, more precise questions? Are we going to help them explore those interests rather than just giving them facts and information, which, we can do. We have a lot of facts and information available on the internet, but just giving them facts and information isn't enough, because that doesn't tell them how things are connected, and it doesn't allow them to reason things out logically. And that's what they need to do at this age, think for themselves.
Actually, they learn how to study by learning what questions and how to ask questions.
Yes.
Is it difficult for an adult to change? Because as a parent, you have a child until of 6, right?
Mm-hmm.
And then you were used to a kind of attitude, perspective, that my child is like this. Is it easy to change? Because it's a huge change for the parent too.
It can be a hard change to make for some parents. But also, I think it really depends on the parent as an individual, the adult, because sometimes some adults find it really hard to work with those children under 6. They're like, why can't you just think for yourself? Why do I have to show you everything? Why do I have to do things so slowly? Why don't you get my jokes?
Yeah.
Those children under 6, they do have different needs. And, when parents become parents for the first time, they're very uncertain what to do. And some of them feel actually a big sense of relief when their child finally gets old enough to dress themselves and finally is able to, go to school and to learn and to have these reasonable conversations. So it's not really about, is it hard to make the change? It's that, are you prepared to make the change? And so we offer to parents, who are expecting children, we offer them, what to expect while you're pregnant. We have books. Mm-hmm. We have classes for parents, how to create a safe environment for your newborn child, what you can expect the child to be doing. And I think that's how we help prepare parents for this change too. We have to talk about, what are those changes that you're going to see? What are the characteristics of that child? And this 6-year-old is curious, wants questions answered in a way that makes sense to their mind. Mm-hmm. And they're not satisfied anymore with the, I'll show you how to do it. Now you do it this way.
They have a chain of questions sometimes.
Yes. Well, why do I have to do it this way? Well, because that's how I showed you. Yes, but why did you show it this way to me? What if I did this instead? What if I did this part first and then this other part? Would it still work? And it's a lot like the children interacting with the world physically when they were younger. That, as they're learning to walk, they discover which furniture is stable that they can pull themselves up on to stand up, mm-hmm. and which ones aren't so stable. And they learn that through trial and error. They make mistakes and they go, oh, that didn't work. And sometimes they change, I think of this table here. They grab one corner near a leg and the whole table comes. But if they grab 2 sides, it actually works for them. So it's not just about the object, but it's how the child interacts with the object. Mm-hmm. So these older children, these 6-year-olds, they've experienced that sensorially, physically with the environment. Now they do it intellectually. Now they imagine what the possible outcome is. And they wonder, well, if I do this little bit differently, will that change the outcome? And that's actually very much like a scientist. Yeah. That's how our scientists work as adults. And I often think of this age as, scientists and philosophers.
And thinking about imagination, you mentioned it, that plays a huge part in their learning at this age. Because if they naturally ask that question, what if? Yeah. They have to be able, or they become capable of making up an answer to that. Right? Mm-hmm. So mm-hmm. Imagination should play a huge part in the way they learn. What does that mean for us as adults?
Well, it means that we have to offer them more than just simple objects in the environment. Mm-hmm. And for one of the ways we do it is by telling stories. And actually, that's something human beings as a whole species enjoy. Mm-hmm. Because we are social, we tell stories to share our experiences in the world. And the stories are really about everything and anything. They paint a big picture. They often offer partial answers that you can then talk about further. Mm-hmm. You can discuss further. They show how people in the past have done things and responded to situations. But the other thing about stories is that we can, through story, talk about the past. Mm-hmm. We can talk about everything in the universe, even if I can't get to Africa as a continent or Australia mm-hmm. To visit. I can, through listening to people talk about their own experiences, what it's like.
And you can construct that experience in your own mind.
Exactly.
Because they can imagine.
Exactly. Someone, I've never been to the Amazon rainforest, but I can imagine what that might be like because I know about rain. I know about plants. I know about humidity in the air. I know about heat. And so if someone starts to describe to me some of those aspects of the Amazon rainforest, the huge plants with enormous leaves that are, sometimes as big as a 6-year-old child, that people have leaves that are so big they could be used as an umbrella. We start to paint pictures where it's hot and humid, where you hear the buzzing of insects, the croaking of frogs. We can really paint a picture with our words that allow our minds to travel there in our imagination. And for these 6-year-olds, the 6 to 12-year-olds, it's just such a powerful thing. We know if we close our eyes and listen to music sometimes, we can imagine different things. Some people see colors, some people see scenes. Musicians, they tried to write, composers tried to write music that could evoke the image of a river traveling by and the different scenes that happen, the sounds of animals. So we have powerful imaginations as human beings, but never as powerful as they are during these 6 years.
And if we think about our own school, my own school, I remember this power being used so little. And that's probably why some children really get bored in school, because they don't use this muscle, as you said before. This is like a muscle. And the children, if they don't use the imagination, this power, what happens to it?
Well, it gets weaker, and you can't use it as much. I think that's why often recess was our favorite part of traditional school. Because that's where our imagination was able to get engaged. We could play games with our friends, and we could imagine ourselves as explorers or climbing trees in the jungle, even if it is just a climbing structure. If we don't keep using it in many different situations, like any muscle, it gets weaker. And then it gets to be hard to use it, and maybe even painful. And we have to, if we want to build that imagination up again, it takes effort on our part. And we have to practice doing it. And as we get older, we're less comfortable with making mistakes. Because we've learned that in traditional school, often mistakes aren't a good thing. You don't want
penalized.
Yes, exactly.
In a very soft way, in a way, but sometimes even, we have marks.
We have marks and grades, and it keeps happening over and over. So we learn mistakes are bad, being correct and perfect is good. But life, well, we're always making mistakes.
There is no learning without mistakes.
You can't learn, because it's actually the mistakes that make your brain pay attention. And that's the interesting thing. Your brain has this wonderful predictive power. It imagines, if I do this, this is the consequence. And that's one use of our imagination, not just being creative and imagining places we've never been, but predicting the future. And our brain likes to do that. And when everything happens the way the brain predicts it's going to happen, it's very happy. And the brain, being very happy, says, there we go, I was right. But when something unexpected happens, the brain stops and says, wait a minute, what was that? That's not what I expected. And so our brain pays more attention. Sometimes the unexpected can make us laugh. The young child playing peekaboo, where they've suddenly discovered, you haven't disappeared behind, vanished. You're still there. It's just there's something in the way. Humor, comedians on stage that we go and visit as adults, and we go and we listen. That's one of the ways that they use humor, is they give us an unexpected ending to a story, and that makes us laugh. So experiencing something that we can't predict is good. Experiencing something that we predicted incorrectly can sometimes make us feel unsafe. It can always, though, help us pay more attention to what's going around. And if you're trying to learn something new, if you always predict correctly, your brain becomes
bored
and just says, I got it.
Predictable.
Yeah, I know this. I've seen this before. Yeah, I understand. I get it. Often what you hear children saying some in classes and they don't want to repeat things. And so the adult then says, well, you have to do this again because repeating is good for you. That's how you learn. Yes, repeating is how we learn, but not when something is too easy, when our brain can just predict it.
Mm-hmm.
But it also can't be too hard. It can't be where we can't find the pattern or find that, we got it right this time. Okay, what was different from before? Can I get it right again? Oh, I didn't get it right again. What happened? So when you get it right is why you get it right. And when you get it wrong is why you get it wrong. Exactly.
So the attitude is the same when you get it right and when you get it wrong. So that the child can learn from both.
Exactly.
From both.
That idea that let me think about, let me reflect on what happened. Let me observe what I did and observe the result. And whether, did I change my actions? Did that change the result? What if I did it this way? Do I get the same result? Right back to those questions that we were talking about earlier.
So what you're saying is that naturally the children are learning through experiments because the mistake is part of an experiment. If we don't accept learning as an experiment, then we want the children to become machines that give the right answers in a way.
Yeah, exactly. And I think, previously, there was more of a need to know facts and sort of to memorize information because otherwise we couldn't easily remember it. Like there was nowhere really to go that we had at our fingertips to get the information. It had to be in your head solidly. And we're now in a different age where facts and information are easily accessed through the internet. The phones that are everywhere with us, or the smartwatches that people are now wearing, our computers. So now that older way of just sort of memorize these things, learn this piece of information, has actually become less relevant for children. And now even more so, children are like, why do I have to memorize the names and dates and places of these historical events, for instance? Because I can just look it up. Mm. And so there is a role, though, for memory, because if you don't use it, you lose it.
Exactly. It's another muscle, right?
It is. So there is benefit to learning things, but now we really can be more particular about how we approach that. What are the things that are really necessary? And that's, I think, one of the powers that are important in our Montessori approach, because we do something where we isolate a particular skill. And I like to think of squeezing a sponge. Because that's, it's a process. You have to get the sponge all nice and wet. Then you have to pick it up, move it over to another bowl, squeeze as much of the water out as you can. And depending how strong your hand is, you'll get more or less. And then you put it back and you get more water and you squeeze it. And that skill of squeezing a sponge, getting all the water out of it, doesn't seem like much by itself. But if you think about all the things we can do with a sponge later, when we're cleaning, for instance, washing a table, putting soap on, getting soap off of things. In the 3 to 6 classroom, we use a sponge for cleaning a lot of different things. When we're practicing squeezing a sponge, we're also strengthening our hand muscles. So that's going to be important later for holding a pencil and writing. That's going to be important later for carrying things, for using tools as we get older. So there's always this skill that needs to be in place in order to do something else later. And that's the same thing as accessing the internet. To get the facts and information, you need to be able to read. You need to be able to ask questions. Yeah. And you need to be able to use the right words, the vocabulary, the keywords. that will help you get the information that you really are interested in.
Choose relevant information from what you find also.
And then read it and assess, is this good information, bad information? Is it reasonable? So those are all the skills that children need to learn and develop so that they can use all those wonderful tools that are out there. Mm-hmm. So we want to, take advantage of how children learn naturally to give them those possibilities.
Going back to memory, because memory is an important process that is involved in learning. But maybe we could think about the time for memorizing things. When is it relevant for the child? When is useful for the child to memorize? Because you can learn the multiplication tables, but that doesn't help a lot. What do you think it should be behind memorizing things?
Well, first, it's experience. We memorize things that we need to use on a regular basis. And we don't think of it as memorizing because really what it is we practice things so that they become automatic. We talk about memorization because, in testing, you have to memorize information to be able to give it on the test. But really, we're practicing things so much, we overlearn them so that they can become automatic. And that's what we're thinking about and looking for. So memorization of math facts is one thing, but you need experience to know, when do I need this? How do I use it? When can I practice it? And for that 6-year-old child, why is it important to memorize math facts? We do it without thinking about it. So let me use the example of walking, because you know how to walk. I know how to walk. Yeah. We learned at a very young age, and we've been doing it our whole lives. And at first, we made a lot of mistakes. The first thing we had to do was be able to get up, to stand up, so that we could start to walk. That in itself was a huge process, with a lot of falling over and overbalancing and probably some tears shed along the way. But we started to walk. And walking is this odd thing that humans do, because it's a little bit of you're always in the process of falling. As you have to lean forward and let your foot catch you so you don't fall to the ground. And I've been walking for a long time in my life, not my whole life yet, but most of my life I've been walking. I still trip. I still stumble. And sometimes I fall down. I make mistakes even still. And when I reflect on when that happens, it's when I'm distracted. I'm paying attention to something else. And it doesn't mean that I don't know how to walk. It just means my attention goes somewhere else. So when we make something automatic where we overlearn it, it does mean we can do other things at the same time more easily. So you and I could be walking down the street having this conversation. And for the most part, we'd be fine unless something, came in front of us that we weren't expecting because we weren't paying too close attention. So that's kind of what we want to have happen when we memorize things. Doctors or chiropractors or any medical profession, they in school memorize the bones and muscles and their names of the body, not because they need to know the name of a particular bone and muscle, but because when they understand how those all fit together, they are more accurate in diagnosing and helping their patients. So math facts for children are memorized. Why? Because they need them in other areas of math. And because memorizing the math facts will make their other work in bigger things more efficient. So for instance, memorizing your multiplication facts helps you do long multiplication more easily. Yep. Memorizing addition facts.
They don't have to memorize it all in order to do the long multiplication, because again, they will find out that, I don't know this combination, so I have to learn it. I have to keep it in my mind. So next time I don't have to stand up and go look for the answer.
And the nice thing too is that if they know some of their math facts, then when they're doing long multiplication, they're like, I know this one. And then they just keep going. And so they have the experience of why memorization of the math facts is helpful for them. And they have the experience of going, this one I know. Oh, I didn't know this one. That made it harder. And that reflection of saying, maybe I should take a little more time and work on those to make this other thing happen more easily and more smoothly.
And also, I was thinking maybe memorization is maybe the last part of learning, because they now understand, speaking of multiplication, the examples you gave, they know what multiplication is. They have experienced it sensorially. They have learned it through so many materials they have in the classroom. Memorizing multiplication means that you understand the process, you practice, and then at the end you get all the facts.
Yes. Yeah. Memorizing is one step in that whole process. It's not always necessary. Memorization is a skill, and some children really learn to memorize well. The problem with when you memorize something is that if you don't keep using it, you lose it. You forget. And that's why some children perform really well on tests because they have a good memorization strategy. The problem is that if you were to give the children a test, you say, we're going to have a test, here's what you need to know, memorize it, and you'll do well. You give them the test, and they do very well. But if you didn't tell the children after that first test, and you came back a week or 2 weeks or 3 weeks later and gave them the exact same test, the children who'd memorized for the first test will have forgotten almost all that they memorized on that second test. Because it was just surface learning. It didn't go deep. It didn't become something that they understood. They just memorized it. If you think about formulas in mathematics and science that we had to learn for school as high school students, I've forgotten most of them. Perhaps you have too. But I couldn't even go back necessarily and rebuild those because it was just a memorized formula. Just learn this, a squared plus b squared equals c squared. What does that mean again? I don't know, but it's a formula, so just use it. Plug in the numbers and you'll get the right answer. But when you have the opportunity to say, where did this come from? What's the story behind the formula? You start to understand why it was important for people to discover the formula, to apply it. And then if you forget a formula, like, area of a circle, you had to memorize that, I bet.
Yes.
You may or may not remember it.
No.
It's pi r squared. But if you forget, well, what's r? Well, I don't know. I don't remember. What are the parts of a circle? I don't know. I don't remember. But if you know that the formula for the area of a circle is all about the relationship of the different parts of a circle, that when we think about area, we're always considering a shape in relation to a rectangle, because we can recreate any shape into a sort of a rectangle, and then we can rediscover the formula for area for that shape. If you understand that process of how we discovered formulas in the first place as human beings, then even if you forget the formula, you can reconstruct the formula with your imagination, with your reasoning, logical, processing mind. And so, sometimes I'll admit I have forgotten the formula for area of a circle, but I can quickly rebuild it in my mind because I know that there's a relationship between circles and rectangles. And so I can find it again. And so it's not a memorized formula anymore. But if you were to, ask children who'd memorized formulas to remember them for 3 weeks, it's gone. And, even as adults, psychology studies have shown in the past, I forget the exact percentage, but it's a huge percentage that's gone within 2 weeks, and then even more within 6 months, and even more within a year. So we do forget. And I think that's something else that's really important to remember about learning with children. They go away for the summer,
Yes.
And they come back in September and they forget. And sometimes for parents, that can be really hard. They're like, well, you said that my child knew this at the end of the year, but, I was talking to them in July or August and they didn't know it. Well, they weren't using it. They've forgotten. It happens.
And that's natural also.
And that's natural, yeah. Teachers come back after the summer in September and go, remember when we were working on this at the end of last year? And the children kind of go, no.
We never did.
We didn't do that. But for the Montessori children who have the materials, when you bring out those materials and the children see those, they start to imagine what they were doing with the materials because they were actively manipulating the materials and working with them and creating things. And suddenly they go, oh, wait, maybe we do remember. Mm-hmm. And they start to, without thinking they know, they start to do with their hands what they were doing before. Mm-hmm. And then you can say, okay, so talk to me, tell me what you were doing. And they start talking to you and telling you in their own words what they had experienced, what they had done before, and it comes back to them. And when you go through that process with the children, it's wonderful to see them go from, I have no idea what you're talking about, puzzled, confused look on their face, to the joyful, we do know, we remember, and they're able to tell you. And that's the power of activity in learning.
Another aspect would be reaching abstraction in learning. Because yes, for the first 6 years of life, children have to experience everything sensorially. All the concepts that you learn in the elementary, they are actually built indirectly in the Casa dei Bambini in 3 to 6. So what is going to abstraction? What does that require in terms of learning skills?
It needs experiences. First, it needs to build on actual experiences where you interact with objects in the environment. It requires you learning vocabulary, keywords to help you precisely describe what you see happening.
So your own experience.
Yeah, your own experiences and observation, where you observe what is happening, what is being done, and the consequences of that. It involves you being actively engaged in the process. And that means thinking about things. One of the reasons we can engage in when we listen to stories is we're imagining things. We're thinking about what's happening. We're predicting what might happen next. Sometimes we're thinking about what we might have done in a situation that would be different from what the characters do. Or we try and help the characters figure out what to do right. So we're engaged in that process. For learning more traditional kind of academic things like language and math, the children still need to be engaged in the same way. So the materials we have in the classroom still need to be present and still need to be used by the children in the 6 to 12, not just in the 3 to 6. We always have to start with concrete sensorial experiences. But then our imagination can start to take over and we can start to think about things that we've experienced and imagine them in our heads. So working with the materials and trying to cut the circle to make a rectangle. We've done it. We've seen the parts of the circle that are connected to the parts of the rectangle for finding area. And then we can start to, instead of having to manipulate the material, we can remember manipulating the material. We recreate what happened in the past experience for us. And we can use that recreation to help us think about the process. And then we can write it on paper with pencil, which is abstraction. Abstraction comes from a word that means to draw out. And it's that drawing out of things that is abstraction. We often think, if you're doing something on paper and pencil, you've abstracted. But not necessarily.
Actually draw out of your experience. And
exactly.
your understanding.
Yes.
things.
Yeah. So when we see children working with pencil and paper and who have not had the Montessori experience with material, we think, oh, well, see, they're working abstractly. They can do long multiplication on paper with a pencil. So they've abstracted. And actually, they probably haven't. They've probably memorized an algorithm
Yes.
to do long multiplication, which is possible to do. There is an algorithm is simply the steps laid out that you follow, each step in order to get to the right answer. For instance, multiplying decimal numbers together. There's a trick, right? Count the number of decimal places in the first number and the second number, add that together, and that's where the decimal point goes in your answer. But why does it work? The power of understanding why it works comes from the experience with the material. So even if you forget the rule that you memorized, you can figure it out again because you understand why that rule works.
And the material helps you because it kind of tells you exactly what to do.
Yes.
It's sometimes self-explanatory. We have colors which keep the place of category.
Categories.
Yes, we have the word order in Romanian.
Yes.
Yes. So yeah, the color helps you because if it's green, you know it's either a unit or 1,000. If it's blue, it's definitely a 10. So you know what the place, what that is when you see the colors.
Yes. And then building on that foundation in the 3 to 6 in the elementary, we say it's not just that it's a unit or 1,000. It's actually a unit in this simple family of numbers. It's a unit in the thousands family. It could be a unit in the millions family. And we help and tens too. Tens of the simple, tens of the thousands. There's a tens of the millions. We use the imagine to go beyond what the material offers us. And what we help the children really do, they've already started in the 3 to 6 seeing this, but in the elementary, in that 6 to 12 class, we really think about the patterns that we can observe in everything, not just in mathematics, but there are patterns in the languages that we speak. There are patterns in nature. There are patterns in how animals live their lives, patterns in how the stars and all those heavenly bodies move around in the universe. There are patterns that allow us in numbers to discover a formula. I mean, that's what rules and formulas are. They are an expression of a pattern that humans have observed over time appears to always be true. And that's what we're helping children to do when they learn, is to observe the world, look for the patterns, and then be able to express that pattern in their own words.
What is usually happening is that we learn the conclusion of those people experience. And we memorize their conclusion, but we forget to look at the way to the conclusion, their experience that themselves had to reach that conclusion. Why is this shortcut? Why do we take the shortcut?
Well, I mean, I think because we know it is a shortcut. You know, it's faster to just follow the pattern of how to find the decimal place by counting how many numbers and just putting it there. It's quicker. It's more efficient. And that's, you know, the brain does look for shortcuts and that's part of that overlearning.
But that works for the adults.
It does
sometimes.
Sometimes. It doesn't always work for humanity as a whole. Sometimes it does. But, you know, we want to be efficient. As we get older, sadly, we have less energy. We don't have the same amount of energy as young children. We don't have the same patience to take the time it needs to do things unless we have a deep, passionate interest in something. You know, I think about the paintings, some of the famous paintings around the world, you know, the ceiling of the Sistine Chapel, or all the painting that Pablo Picasso did in his lifetime, or the writing of novels and stories. If those people did those huge pieces of work, that big, great work, because they had a passionate interest that drives them and says, I want to do this for me, They didn't do those things for other people necessarily.
Yeah.
They were doing it because they had something inside them they wanted to express. And that's a need we have as human beings. We all have that need to express ourselves. And we do it in different ways. And they were interested in that. They were motivated to do those things. They were motivated to learn new skills, to play with colors in new ways, to try different techniques. And so those were adult human beings who continued to develop their skill, continued to hone their craft, to become better at what they're doing. They kept learning. And that's why now we look back in history and look at some of these great artists and great writers, and we think, wow, no one ever is going to be able to write like that again, or there's so few people who paint like that. Well, they paint and they wrote like that because they practiced it. They made mistakes. They didn't just, one day go, ta-da, here it is. I did it in an hour. This is the Mona Lisa. No, it was time.
Well,
it
yes.
was practice. There was all this
labor,
this activity, this imagination happening, this thinking things through, errors and mistakes that eventually led to this thing that many of us would say, oh, it's perfect. But even if we talk to the artist, they look at it and go, no, that's wrong. This is wrong. I'm not happy about this yet. They're still critiquing themselves from their perspective of what they understand and they know, which is far more than you or I. But they can do that because they've spent a lot of time learning.
and they most probably they didn't think about efficiency so much, right?
They did not think about efficiency.
And they didn't think about learning fast and as much as we can without the relation between what they learned.
Yeah, and they certainly didn't do it because someone said to them, you have to do this.
Yeah.
I'm sorry, Pablo Picasso, you are going to have to paint. That is your job. That is what you're going to do, paint. Oh, and by the way, for these few years, you're only allowed to use shades of blue.
Of course, they had deadlines.
Yeah.
They did have deadlines. Some of the orders from some kings or some high people.
Yes, and symphonies too.
Symphonies too,
Yes.
but
Yes.
they did have deadlines, but they were not told exactly how to do, what to do.
No.
They were the ones who decided.
Yes. But also, those people who were ordering those symphonies or ordering paintings, they weren't going to just anybody. They were going to people they knew who had some skill already and had shown some practice and some knowledge of what they were doing. No one would have come to me to ask me to write a symphony or to make a painting. I just want to say that, because I don't have those skills.
Yeah.
So there was already learning that had to have happened. They had to have achieved a certain level of competence. And we're much more interested in learning what we're interested in as human beings. And sometimes we learn things not because we want to, but in the moment, but because we know it will help us do something later on. And if we have that long-term vision as adults, that can motivate us to do hard things. So for instance, I know that I'm going to travel to Romania. I might spend some time at least learning some basic words in Romanian. So I can say good morning, good evening, thank you. But I'm not going to hold this kind of conversation in Romanian. I just don't have that language level. So we learn things because we're interested, because we have a goal that we want to reach. And that's how the adult mind thinks. Children, on the other hand, they live much more in the moment. They're not thinking about, well, when I'm an adult, I'm going to be a lawyer, so I need to know all about Latin words, so that will help me with legal terms. That's an adult reasoning about learning. Children are more about, well, why do I need to know that now? How is that going to help me now? I mean, adults are saying, how's that going to help me in the future? But it's still about, why is it important to me? So do I have the interest in learning? Because when we're interested, it's always much easier to learn something.
That's another key word for learning, interest.
Yeah.
To keep the children's interest in learning, we need to answer their needs.
Yes.
And you mentioned so many things like imagination, reasoning mind, the need for language, and so on. So keeping the children's interest is an art.
Yes, it is. It is just like painting is an art. Yeah. Yes. Working with children and understanding their needs is so important. And I think that's something else that's very different for these children who are between 6 and 12 than the under 6. And that's that need for social interaction, not just for adult child or listening to an adult talk to the group, but with each other. Because learning is a social activity. We learn more, we're able to do more in a group. That group is essential. And you see it with children who are in a class where, the teacher is trying to keep their interest, but not because they're not putting it in a story context or they're talking too many facts and information. And what happens to the class or to the group, they start looking at each other. They start talking with each other. If they're not allowed to talk, they start writing notes and trying to pass it without the teacher noticing.
We used to do that, right?
Oh, yeah. We all did that kind of thing in school because our interest wasn't being held by the teacher. And so what happens often in a traditional classroom is, well, this is going to be on the test. Oh, now you've caught my interest. I need this because I want to do well on the test. I need a good grade on the test, or, my parents aren't going to let me watch TV for a week. If I don't do well, there's this reward and punishment thing that happens in a traditional classroom. But if we think about children, they're curious. They want to learn. So we don't need to use rewards and punishment in this way. What we need to do is ask ourselves, what is really interesting to these children? And what is really interesting to 6 to 12-year-olds is everything, as long as we put it in this context of how are things connected to each other. Yes, some children have passions about certain things. Children, the 6, 7-year-olds are very interested in animals and plants and how to care for them and what they can do. They're very interested in the large and extraordinary. They're interested in the very small things too, like atoms and molecules. These children, because they're thinking about society, are very interested in what other people have done, what they do, because they're looking for, what does it mean to be an adult in our society? What do adults do? What sorts of things do I want to be able to do? So they look for role models. And they look to all the adults that live in their lives. They watch them carefully. And they ask them, so how come you get to stay up later than I do? What's up? I want to go to bed when you go to bed. I think that's fair. How come I have to clean up my room, but you're going to sit and read a book? Why do I have to read a book, but you're going to watch TV? They do a lot of that questioning of us as adults, but not because they're trying to be rude or anything, but because they're trying to figure it out. And they look everywhere, the sports heroes. I often, remember, and I still see children imagining themselves as they play football and saying, I'm Messi, and trying to act and behave like they see their heroes acting and behaving. So we can bring them stories about all these wonderful people. We can tell them stories about Michelangelo and Leonardo da Vinci, about Marco Polo, about all these explorers and people who've done wonderful things. But we can also tell them stories about individuals and groups of people who are alive now and the things they're doing. And that's interesting to them because it's real people doing real things. So if we know what the children's interests are, we can bring them things. And elementary children, 6 to 12-year-olds, are interested in everything. We just have to bring it to them in a way that sparks their curiosity, engages their imagination.
That's the art, right?
And that's the art. Yeah.
Yes.
Yeah.
Thank you very much, Kyla. Thank you.
Thank you. It was love. I love talking with you about these topics. They're deep.
They're deep. Yeah. And we discover more
every time
while we talk.
We do. And it's great to have that opportunity to reflect. And
Thank you.